Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our Modern C++ series. In this lesson, we're going to be talking about performance, and a way to hint to your compiler, a way to get more performance by inlining functions. So in this lesson, I'm going to be talking about function inlining specifically. There's other things that you can do for inlining, like inlining variables in Modern C++, but let's just go ahead and look at functions for now, and we'll revisit other use cases of inlining later on in this series, so make sure that you subscribe to check that out later. All right, well, with that out of the way, let's go ahead to our favorite website, CPP Reference, and look at the inline keyword here. And again, this is a keyword, so you can go ahead and see that it's here. But today I want to focus on functions in particular. That's sort of been the long-term use case of inlining and ways that we can inline in C++ specifically. And what we'll go ahead and see is with this inline specifier, which is put right before the function, that's all you have to do here, is it tells the compiler, or rather, I should say, it just hints to the compiler that you want to perform some sort of optimization, specifically function inlining. So we can go ahead and click on this and find a detailed explanation of inlining. But if you want, instead of the Wikipedia, I'll go ahead and give you another source here, compileroptimization.com. You can search for function inlining here, and I'll give another explanation here, and I'll go into the pros and cons in a moment here, but I just thought that was a nice site. But I think the best thing to do is to talk about this in the terms of Compiler Explorer and to just sort of illustrate what's going on. Now, the example I'm going to give you is relatively simplistic here, and that I've got an add function here. So just taking in two arguments, A and B, and returning the sum here. I've put auto here. I could just as easily put int here, but again, I like to show off some modern features here every once in a while. So clearly we can see that the value here that's going to be stored is 9, and then we return that value and so on. Now, in order to sort of orient you of what does function inlining get, I want to go ahead and just show you a little bit on Compiler Explorer and illustrate on the whiteboard in a moment what happens when you call a function. So here again, I'm highlighting the add here at line 3, 4, and 5, and you can see the associated assembly, which I'll highlight here on the right. Now what this is doing here, and I'll highlight all of it here, is the actual function call for add. So again, this is behind the scenes what happens every time you call add. In fact, I'll scroll down here a little bit in what's our main label here, or main function, and we can go ahead and see that there is a call to this function add, which will generate our result and store it into value, or rather move the result into this value here in assembly terms. Okay, so what exactly is going on again when we call a function, and why does function inlining help us? Well, the idea is if I have some function here, and I'm just going to sort of make it abstract here, the idea is I'm going to have some arguments that I need to produce here. I've got my body of code, and then I've got other things like the return value and also the return address. Now, how these are exactly laid out might depend on your architecture, but I'm just abstractly representing these here. And again, we might have multiple arguments here. So the basic idea is, again, if I just have some function here like add, and I'm making use of this in my main program. So let's just label this main CPP, and I have main here. And every time that I call add and compute some result, well, effectively, I have to go up to this block here, or this label. So I'll put a little colon after it, so you know the assembly. But I have to create what's called a sort of frame or activation context to do this function call, which again results in maybe making copies of the arguments, performing the actual work for the code, storing the return address, so I know where to jump back to after I've done my add, and of course the return value, generating that value. So this can be a lot of work here. But what I really might want to do is just take the body of code and insert it into this add here. So I can just go ahead and scribble this out here and just do 4 plus 5, because really that's all the add function's doing here. Okay, and let me just rewrite it here so you can see very cleanly 4 plus 5. That's all the work that's being done. No need to copy things, store return addresses, and so on. And you can imagine for such a small function like this, we're paying an overhead to copy these arguments, store a return address, and jump back and forth. In fact, this has other hardware implications as well, because we're jumping somewhere else, and the performance benefits we can get from our hardware by making simple code in terms of guessing what instruction to execute next, and this is a principle known as locality, is often harmed when we make lots of function calls like this. So inlining again to the rescue, just compute the result here. And not only that, if we're just doing something like add, a simple 4 plus 5, for instance, we can even start performing other optimizations. So for instance, let's just compute this as 9. So we don't have to copy the individual values of 4 and 5 together, but instead we can just say, hey, I have 4 plus 5 here, and just make that the value 9, as indicated here. So inlining in this way, function inlining specifically, can enable other optimizations. So very briefly, I want to go ahead and recap some of the pros here. So you get this benefit of locality, so I'll put a plus here, meaning that we can guess the next instructions easily. And by we, I mean our hardware. We get other optimizations enabled. And that's where I was just able to say 4 plus 5 could just be transformed to a 9. And again, that's going to depend on your compiler, but we're enabling that possibility at the very least, and so forth. Now, on the cons, though, my code size increases. Now, in the case of add, maybe not, but what if this body of our function was very large and we were just taking that and copying and pasting it into our main function and perhaps doing this many times? So now we're kind of paying some price on our executable size, and maybe other things would be affected. So we do have to keep that in mind. And we might also pay a small price here when it comes to debugging. Maybe more difficult. Meaning that we've sort of lost this control flow of which function's being called. So again, our debugability, I'll move out of the way for a moment here, can cost us something because we don't have this nice call to add anywhere. We just know we had this 9 that showed up somewhere in our code. All right, so with that said, though, let's go ahead and play around with this just a little bit in Compiler Explorer so you can understand how inline works now that we've talked about how it works and some of the pros and cons. So again, I'm going to just start with the add function here, which I'll highlight on the left side, and we can see the assembly that was generated for this. Now, if I want to get rid of this add function in the sense of inlining, let's just go ahead and add inline. So that's our keyword, or again, our hint to the compiler that we might want to get rid of this. So to know if this worked, we'll just sort of scroll through our code and see if it worked. Well, looks like I still have a call to add here. Now it sort of rearranged things a little bit, but it's still there. So how can I get rid of add here? Well, again, sometimes it's up to the compiler to choose. So one thing that we can do here, if I'm using GCC, for instance, and Clang has similar things, is I can add an attribute, and I'll expand this just a little bit so you can see. And basically what I want it to do is always inline. So it's always going to take my hint to the compiler here, and it's going to say, I always want to inline it. And sometimes you'll see folks add this attribute and inline on a separate line here. So that's what I'll do here, just so you can fit things nicely. And now if I look through my code, well, what do you know? There's no label for add here at all. So we've successfully gotten rid of our function. So again, if I kind of highlight this here, then let's go ahead and see what I'm doing here. Well, I'm moving, well, let's actually see if we can find our value here. We're moving 4 and 5 into some different registers here, and effectively computing our result of 9 that we return. Okay, so that's the idea of always inlining. Now, there are some things again to remember that this is just, we really want to know what we're doing here, because for example, if I'm doing a bunch of operations here, let's just create some, I don't know, garbage here. Basically, I just want to create a bunch of other variables here that we can kind of see here. Let's create D and E and F and G. And I'm just kind of expanding this body a little bit here. Let's go ahead and see if this gets inlined in our code somewhere. Well, let's see. Well, I see my E here. which again, just to make it a little bit easier, I'll make these different numbers here. 7, 8, 9. Good joke for you. Why was 6 afraid of 7? Anyways, as I kind of highlight others, you can see that this code is indeed all getting embedded into our main. So this is what I mentioned about the code size of this function mattering when we inline it. Okay, now this code itself isn't doing anything, so we could probably enable other optimizations to try to get rid of this. In fact, if I do -o of 2, let's go ahead and see if that gets rid of these lines that aren't really doing anything here. And if we give it just a moment to compile, well, you'll effectively see that, well, we're just storing the value 9 here into value. We don't even need value, so we can essentially just return this value here. So that's kind of cool to see that work. Okay, so that's the idea. O of 2 will enable a lot of these different optimizations for us. And if you'd like to see a complete list of those, you can look at GCC and search around at some of these inlining types of optimizations by searching inlining. Now I found one that was nice here that I've already highlighted here that inlines functions called once, just to give you an idea of some of the heuristics that you might use. So if you have a static function, for instance, that's only called one time, why pay the overhead for that actual function call if it's called exactly once? Just go ahead and inline that body of code. The actual organization of the function is just sort of for you. So those are some of the heuristics that you'll see here. And you can explore your actual compiler if you want to learn just a little bit more of how inlining actually works. And as I mentioned, sometimes if you don't want your compiler, even when you're optimizing the code to, again, not inline, you might play around with something like fno inline. So let's go ahead and just do that really quick here. Let's go ahead and do this fno inline. And well, if I've marked this as always inline, it is going to ignore that attribute. So I've got to get rid of it. But even if I have inline here, let's go ahead and see what happens. Give Compiler Explorer a moment to generate some code. And you can see that it's still doing some optimizations here with O of 2, but it's keeping that call here for add for me. Now, again, why was this important? Well, if I go back to our little whiteboard here, right above me, the debugability of my code. I still want to, when I'm debugging this, be able to logically say, yeah, I want an optimized build, but I do need to be able to see, was the add function called before, something interesting happened, or whatever function that you might have. So just a few tips for folks and a little bit of an introduction to inlining for you. So I hope that was useful for you. I hope you can play around with this. I think Compiler Explorer is a great way to sort of see what's going on with your actual code, and I hope you'll enjoy this lesson and make sure to look out for the next lesson where I talk about inlining variables. With that said, folks, thanks for your time and attention as always, and we'll see you in the next one.